Hi everyone, this is Mahima. I welcome you all to my presentation for the project submission of power plant. So basically, the objective of this presentation is to predict the electrical energy output of a combined cycle power plant that uses gas turbines, steam turbines, and heat recovery steam generators to generate power. So the expectation is to predict the electrical energy output of this power plant using machine learning models and then finalize which is the better suited model for an accurate prediction. As a first step, performed was understanding the data that is provided within the project. So the data consists of 9568 data points, which are nothing but the hourly average readings from the sensors. There are four features that are part of the data set. The first one being a temperature, which is denoted as AT and is calculated in degrees Celsius. The next one is the ambient pressure, which is denoted as AP with values in millibar. The third one is the relative humidity, which is denoted as RH in percentage. And then the last one is the exhaust vacuum, which is denoted as V. As per the objective, our target data point would be the net hourly electrical energy output, that is denoted as PE, and it's in megawatts. After understanding the data and having known the features and the target, the next step is building the machine learning model. Where the machine learning models here, as part of the project, have been built using Python, wherein Pandas, Scikit, Matplotlib libraries have been used. The data that was shared with the 9568 data points has been split as per the 80-20 rule, wherein 80% of the data is used in training the data model and 20% in testing. Two models, machine learning models, have been created and trained as part of the project. The first one being the linear regression, which is a fairly easy and simple to understand regression model. The next one chosen is a random forest regressor, which handles complexity better. So that is the second choice that has been made in the project. Two output matrix have been used and calculated from the above models. The first one being the mean absolute error, MAE, and the second one being the coefficient of determination, that is denoted as R square. I will show you and walk you through the Python code that is used to generate these output values. However, we'll just talk about it as part of the summary quickly. So as we can see that the code generated MAE and R square values both for linear regression and the random forest regressor models. And clearly we can see that random forest regressor has lower MAE, which means better accuracy, and R square value closer to 1 again for this model, which means the random forest regressor is a better fit in terms of predicting the power output for the power plant. And yeah, as you know, the R square value is closer to 1 and MA is again lower. On the right hand side, it also the graph also donates the scatter plot, wherein each point here is basically the prediction that is made, and we can see that a majority of the predictions that are made are really closer to the actual values, helping us understand that why random forest regressor is a better fit over the linear regression. So I will now walk you through the Python code that is being used to generate these outputs. We can clearly see the step-by-step process wherein the libraries were imported. The data that is provided as the sample data as part of the project was loaded. The features definition is the next step, wherein the four features and the target variable is again defined. The data split using the 80-20 rule is done as part of the step 4, and then the linear regression model is trained, followed by training of the random forest regressor. Once the models are trained, the results MAE and the coefficient of determination values printed, and followed by the plots helping us understand the value comparison of MAE both for linear and the random forest. And then finally the scatter plot that was also part of the presentation, explaining how close the predictions were made by the random forest model. So I will now run the code to show the values generated. We'll just wait for the code to run and have the output values created. It will just need few more seconds before it displays the results that were already included as part of the final slide in the PPT. Okay, so we can see on the screen that the MAE values have and uh, R square values have been created, have been displayed both for linear regression and random forest regressor, followed by the plot for comparing the MAE values. Clearly, 2.33 from random forest regressor is a better value, and then the code also generates the scatter plot explaining the actual versus predictive power outputs from the random forest regressor. So that's all from my side as part of the submission. Thank you. Thank you for going through my PPT.